You are welcome back to Idowu Math class. Another concept we want to consider is expressing whole numbers as a product of their prime factors. That is, how to express whole numbers as a product of their prime factors. Example 1. Express the following as a product of their prime factors. Question A. 45 as a product of its prime factors will be, let me analyze it here. 45. 3 is the smallest prime numbers that could first divide 45. 3 in 45, this is 3 in 4, that's 1. It remains 1 in 15, that is 5. 3 again in 15 is 5. 5 is 1. Therefore, 45 could be expressed as 3 times 3 times 5 as a product of its prime factors. And it could be in index form, which is 3 raised to power 2 times 5. If the question asks you to leave it in index form, it is then mandatory for you to leave it as 3 raised to power 2 times 5. The question B, that is 72. Let's see the way it is expressed. 2 in 7 is 3. Remains 1. In 12 is 6. 2 in 3, 1. In 16, 8. 2 again, 9, 3, 3, 3, 1. So, 72 is expressed as 2 raised to power 1, 2, 3 raised to power 3 times 3 raised to power 2 in index form. 72 is expressed as a product of its prime factors as 2 raised to power 3 times 3 raised to power 2, though in index form. If the question does not specify whether to leave it ordinarily or in index form, you are free to leave it in any way. But once the question demands for index form, you have to leave it like this: 2 raised to power 3 times 3 raised to power 2. Then C, the C part, which is 102. 2 can divide 102 as 2 in 10 is 5, in 2 is 1. 3 can divide 5 once, remains 2. In 21, that is 7, then 17. Therefore, 102 could be expressed as a product of its prime factors as 2 times 3 times 17. 2 is a prime number, a prime factor of 102. 3 is a prime factor of 102. 17 is a prime factor of 102. So 102 is expressed as a product of its prime factors as 2 times 3 times 17. Example 2. Express 480 as a product of its prime factors in index form. That is 480. 2 is the least prime number that could divide this. 240. 2 again. 120. 2 again. 60. 2 again. 30. 2 again. 15. 3. 5. 5. 1. Therefore, 480 is expressed as a product of its prime factors in index form as 2 raised to power 1, 2, 3, 4, 5. 2 raised to power 5 times 3 times 5. And that is it. The next concept here is lowest common multiples, LCM. I will rather explain this to you through example for better understanding. Example 1. Find the LCM of 60, 48, and 36. There are two methods we can employ, and I'm going to teach you the two approaches. Number 1 is the long division approach. In the long division approach, you write the numbers involved, then you divide by any available factors that could divide either all of them, or one of them, or two of them. 2 in 60, that's 30, 24, 18. 2 again goes in 30 15 times, in 24 12 times, in 18 9 times. 2 can still divide 12, but we repeat 15 since 2 cannot divide it. But it goes in 12 6 times, we repeat 9. 2 can still divide 6. For that sake, we are still using it. Repeat 15. 2 in 6, that is 3. Repeat 9. Now, 3 can divide 15. 3 in 15 is 5. 3 in 3 is 1. 3 in 9 is 3. 3 can still do. So, 3 in 5, repeat 5. Repeat the 1. 3 in 3 is 1. Now, it's the turn of 5. 5 in 5 is 1. Then, repeat this 1. We see LCM, therefore, of 60, 48, and 36 is 2 times 2 times 2 times 2 times 3 times 3 times 5, which could be written in index form as 2 raised to power 1, 2, 3, 4, 2 raised to power 4 times 3 raised to power 2 times 5, or 720. How? 2 times 2 times 2 times 2, that is 16. 16 times 9 times 5 gives us 720. The method you can use is this. 2 times 5 gives 10. 2 times 2 times 2, that's 8. 3 times 3, that's 9. 8 times 9 is 72. 72 times 10, that is 720. That is it. This same example 1, I have solved it for you. Let's resolve it using another method, which we call product of prime factors method, so that you will have a kind of widened knowledge. If you want to use that method, you list the number like this: 48, 36. You now express 60 in index form, or you express 60 as a product of its prime factors. If you do that somewhere, 60, 2 in 60, 30, 15, 5, 5, 1. So 60 is 2 raised to power 2 times 3 times 5. Do the same thing for 48. Do the same thing for 48. 2 in this, that's 2, 4, 1, 2, 6, 3, 1. So that is 2 raised to power 4 times 3. Do the same for 36. And that is 2 in this, 1, 8, 9, 3, 1. So that is 2 raised to power 2 times 3 raised to power 2. Make sure you express the factors in index form to make it easy for you based on the explanation I'm going to give you now. Anytime you want to find the LCM using the product of prime factors method, see what to do. You don't have to do anything after expressing each of them as a product of their prime factors. You write LCM equals, what do? We pick the LCM in this case. We pick every factor present in their highest power. Listen again. Every factor present, we pick them in their highest power across the 3 numbers. This is what I mean. Factor 2 is present. Factor 3 is present. Factor 5 is present. But factor 2 is present in different degrees. Factor 2 is present in power 2, is present in power 4, is present in power 2. According to the principle I'm giving to you now, if you want to use this method to find the LCM, pick every available factor in their highest power. I want to pick factor 2 in its highest power. Factor 2 can be of power 2, of power 4, of power 2. So I now pick the one of the highest power, 2 raised to power 4. I hope you get the point now. Now, pick power 3 in its highest power also. We have power 3, we have 3 in power 1, 3 in power 1, 3 in power 2. Pick it in its highest power, 3 raised to power 2. What other factor is available? Factor 5 is only one, so pick it. That is the LCM. If you look at it, this is the same LCM we got when we used long division method, which could be 720 if multiplied together. Example 2. Find the LCM of 12, 15, and 18. Here we are going to use the two approaches together. I will make sure I divide the board so that we can manage the space. Using the long division approach, we have 2 here is 6, repeat 15, 9. 2 again, 3, repeat 15, repeat 9. 3, 1, 5, 3. 3, 1, 5, 1. Then 5, 1, 1, 1. In that, LCM is equal to 2 times 2 times 3 times 3 times 5, which could be in index form as 2 raised to power 2 times 3 raised to power 2 times 5. Or if you want it in whole number, you can have 2 square is 4. 4 times 5, that is 20. 20 times 9, that is 180. That is it. In the second method, you have 12, 15, 18. Express 12 as a product of its prime factor, so you have 2 raised to power 2 times 3. 15 is 3 times 5. And 18 is 2 times 3 square. LCM in this case, don't forget, will be you picking every available factor in their highest power. Factor 2 is available. 1 in power 1, the other in power 2. So you pick the one in power 2 times. Factor 3 is available. 1 in power 1, another in power 1, another in power 2. Pick the one in power 2. Factor 5 is available once. So pick it. This is the LCM, or we can see that 2 raised to power 2 times 3 raised to power 2 times 5 is what we eventually get here. So, or 180.